okay, if, well, I will just say a little bit things about myself. I'm an architect, and I have recently retired from Istanbul Technical University, Department of Architecture. And at the moment, I work as a full professor at Özyeğin University, Faculty of Architecture and Design. My research areas are mostly related with technology, part of architecture, mostly focused on facade technologies. Well, that's all I think. Well, as you said, this is the last session, 9th session of the conference, and we have a very hot topic, I must say, gamification and e-learning design. And we have 5 papers in this session. And one of them is about gamification, and the other 4 is about e-learning. Well, just I would like to say a few words about gamification, and I can say that it can be described as the use of game design techniques to solve the problems and engage audiences by using technology more and by maybe encouraging desired behaviors and taking advantage of humans' psychological tendency. So at that point, we can say that gamification is the step of converting a product from a function-focused design into a human-focused design. And therefore, games or gamification have been a research subject of interior design in terms of their psychological, physical, and virtual environments. So our first presentation is the title of the presentation is User-Centered Gamified Interior Design Guide. And the co-authors of this paper is Duygu Koca and Ebru Yücesel from Hacettepe University Interior Design Department. And yeah, we have 15 minutes. I forgot to tell you that we have 15 minutes for each presentation. And maybe it's better to have the questions at the end of the session. So, okay, I think Ebru Yücesel is going to present their study. So, okay, Ebru, the screen is yours. Welcome.
Yes, thank you. Thank you. I have a video record actually. Can you share it?
Yeah, I'm sharing it right now.
Okay, thank you.
Can you see it?
Yes.
Hello everyone, my name is Ebru. Today I will present to you our research which is named User-Centered Gamified Interior Design Guide. Today, by taking advantage of game theories and models, gamification techniques are used in order to obtain various gains in areas other than games. This part, which cannot be associated to game, mainly deals with the behavioral components of gaming. Games have been a research subject of design in terms of their physical and virtual environments. By virtue of gamification, the designer who is a factor in the space creation process in game design can be part of the game dynamics by using the basics of the game. In this process, at which point the designer will take an active role in gamified design process and how they will adapt to these mechanical and dynamic components are the issues to be questioned. In this context, the aim of the study is to reveal relationally the mental connection of the designer with the game elements for the gamification application on the design to be designed with the gamification hierarchy asserted by Verba and Hunter. In order to achieve this goal, literature review regarding the gamification and design areas was performed. In addition, 15 people who have received design education and are professionally interested in design were interviewed. The target population of the study is individuals who have received design education, and the sample group was determined as participants who are professionally interested in design.
No, no, faccio
In
io
the
dopo, non ti
process,
preoccupare.
Qua?
Sì, sì.
based on gamification
No, se no facevo.
No,
participants. The questions were asked by the structured interview technique, and the data were evaluated by the content analysis method based on the participants' discourses. At the end of the research process, suggestions were given on the use of game elements for gamification applications, which can be applied to designers. According to Schnabel, gamification is designed as an alternative to the traditional design education. It was also used as a support and a tool for the internalization of knowledge to improve design knowledge. In Design Studio, gamification has no problem-solving method, a tool that supports creativity and application used to increase motivation towards the lesson. According to Verba and Hunter, before the gamification application is designed, all the subcomponents to be selected for the application should be selected by considering the audience and used for specified purpose. In this context, it was observed that the group that will participate in gamification application in the literature reviewer doesn't examine how the group could exist with its user profile. Accordingly, it is thought that the user analysis and the gamified design guide will create a permanent and sustainable experience. The concept of gamification, although gamification is a game-based approach, it is used for different purposes than game and game design. According to Kerem and Nikpoyam, gamification is a different phenomenon that takes the game as a reference and shape around the game. Gamification is also used to bring together certain communities. According to Brigham, when gamification is used in education, it can have collective work by bringing together different student communities. It can also create an opportunity for participants to make mistakes and receive feedback from this mistake in a collective environment. The gamification and game components. Verba and Hunter divided the game elements into 3 different categories in a hierarchical order and included the game components in the gamification process. They dividing gamification into these 3 phases may increase success in expected results. In this environment, game dynamics can improve the story and the social achievements of the game and improve the motivation process for the participants. Mechanics can be used to increase players' participation in the game. Game components can be seen as elements supported by mechanics and dynamics and with which the player interacts closely. In this hierarchical order asserted by Hunter and Verba, game dynamics are explained as constraints, emotions, narrative, progression, and relationship. When it comes to game mechanics, they can be considered as factors that ensure the sustainability of the game in terms of usage and participation. Game mechanics can be listed as challenge, change, competition, cooperation, feedback, resource acquisition, rewards, transactions, turns, and win states. The components in the game elements are the elements that the participants interact directly. The game components are defined as achievement, avatar, badge, boss fights, collection, combat, contact unlocking, gifting, point, leaderboard, levels, quests, social graph, teams, and virtual goods. User analysis research. As one of the 6 important levels in gamification, it should be examined who the audience is and which situations motivate them in general. In this case, what the users think against the act of playing should be analyzed. From this point of view, interviews were made with 15 people who received design education and are professionally interested in design. Questions were prepared on the basis of gamification elements in order to define the role of the designer in gamification fiction. Accordingly, no answer was sought for all subtitles of gamification elements in the interview questions. In this context, the concept of game dynamics, constraints, emotion, narrative, progression, relationship, Game mechanics, challenges, cooperation, feedback, resource acquisition, rewards, game components, avatar, badges, boss fights, content, combat, levels, quests, teams are selected. The interview questions prepared for the participants were set up as follows. In this regard, the participants evaluated the design constraints throughout the design of the entire process, project cost, design programs, and rhetoric of the design knowledge. On the other hand, they saw emotion as a changing phenomenon in analyzing the challenging process of the project, finalizing the design, realizing the design, managing the concept of time, and feedbacks of users. On the other hand, they discussed the narrative item, throughout design and improvement constraints based on riddles that they were reading. Progression was seen as the stage in which the designer would increase his gamification competencies. Participants state that they developed themselves through creative files such as observation, art, literature, travel, and following technological developments and contemporary designs. Relationships were seen as an element that motivates designers, allow brainstorming, improves workflow, and bring the user and designer closer. As for the game mechanics, the elements of challenge were defined by the participants as communication with the customer, technical processes, realistic rendering, and presentation. In addition to that, the element of change couldn't be associated with the design process by the participants. When it came to the competition element, it was seen that the participants evaluated this element through design competitions. In line with the answers received, they described these concepts as a dynamic environment that will make the gamification process exciting and may impatient the designer. About the cooperation element, they state that they cooperate in design process with architects, landscape architects, civil engineers, industrial designers, graphic designers, sales specialists, furniture manufacturers, and artists. They interpreted another mechanical element to feedback on the topics criticized by the designers. The designers described that they were criticized in terms of color, texture, material, application solution, and user requests at the end of the application. Resource acquisition was defined by the participants as geometric forms, drawing tools, elements of the structured production tools. Rewards, on the other hand, were evaluated on the design by user satisfaction, self-efficacy, and professional competence. As for the components of the game, the participants were evaluated in terms of avatar based on characteristics of the designer's character, the originality of the design, and body language, signature, and color use. Participants made statements about the prestigious design awards, financial gain, traveling, vocational training, among the ways of awarding the badge component. Boss fights was defined as the third final task, including planning the time and budget for the designers, choosing the right material, application errors. Combat was described as special limitations, equipmental competencies in the drawing process, insufficient time in research, limited time, and the precision process of the user. Levels were explained as generating ideas, creating concepts, and computer-aided design as a process they have difficulties. They also described that the levels couldn't be explained in a plane that developed from hard to easy. The quest was described by the participants as the design being applicable, detailed solution, communication with the user, personalization of the design, design of the process, presentation, concept studies. Finally, for the team component, the designers listed the site officers, mechanical engineers, architects, landscape architects, civil engineers, electrical engineers, acoustic specialists, art historians they worked with. Conclusion suggestion. The answer of the participants to the questions prepared by intersection the gamification elements and the design knowledge were analyzed with the content analysis method. In the answers received against this intersection, it was studied to analyze the emotional thoughts, perspectives, and attitudes towards the concept that the designer had during the design process. Levels and progress in the gamification process, it can be thought that the design has more organic progress. Coercive elements can be articulated homogeneously to the process. The elements of badges and rewards, the designer tended to have the appreciations that fed spiritually rather than material-oriented achievements. The elements of constraints and feedbacks can be interpreted user customer profile, project budget, design process, limited time, customer and designer relation, application solutions. Both sides can be interpreted on the basis of the last-minute changes from the customer. Quest on the basis companies with the design procedures and principle applicability and usability. Cooperation, relationship, and teams roles can be determined architect, interior architect, landscape architect, industrial designer. Combat can be considered as project budget and time and management. Competition may be motivating in the teaching and research in application. Fiction designers see their characters in an intuitive and creative position. Challenge can be applied to convince the customer about their mistakes as the participant solves a technical detail among themselves. Combat on the basis of budget management. Includes the gamification elements of emotions. It can be said that the designers are proud of the feedback such as appreciation. In gamification, the situation can be triggered by inner motivation such as professional success recognition. It can be said that the control of limited time, lack of information, and negative emotions are triggered. Avatar designs who can be modeled in gamification application can be added to avatar feature. The element of change can be used in selection of gamification tools that the participants interact with other than the design action. Resource acquisition, modular elements, geometric models can be manipulated in the gamification process. In the light of these research and suggestions, gamification studies that will be added to the design process are aimed. It is thought that the designer approach of the study in the use and selection of gamification elements will increase the sustainability of the applications. Thank you for your time.
Thank you, Ebru.
Thank you.
Yes, now at this session, we're going to focus on another challenging area, which is e-learning or distance learning or online teaching platforms. Along with that pandemic period, these topics gain more and more importance, I must say. And the question is how we can combine design courses with e-learning methods effectively in the process of learning experience. And at this stage, the new normal, I must say, necessitates effective development and evolution of the traditional education methods in consideration of new educational models blended with distant learning methods. And now it's necessary to know the efficiency of online teaching platforms, especially for design education, where face-to-face learning is essential. And well, in this context, I must say it's very significant to understand the success of e-learning models with these studies. And also, it's for sure that identification and assessment of potential challenges in distant education in the field of design observed from the standpoint of the participants, such as the lecturers and the learners, are really very important. And of course, at that point, more elaborated survey studies are needed, which means that we have to work on new education models with regard to e-learning platforms. And the Four papers will point some important issues regarding with e-learning design. So let's hear the first one, and it's there are four four co-authors. The title of the presentation is Asset-Based Distant Learning Using Extended Reality. And the researchers are Ertuğrul Süngü, Burçin Gürbüz, Barış Atiker from Bahçeşehir University, and Kutay Tinç from Istanbul Technical University. And Barış Atiker and Kutay Tinç are going to present their study. Welcome, Barış and Kutay.
Hello, and welcome
Hello.
to all the participants. Kutay, would you like to say something? You are here?
Yeah, you can start, no problem.
Okay, cool. First of all, thank you very much for the opportunity to present at this event. It's really an important event for all of us who are designers and developers of these new technologies. So today we are approaching the effects of COVID-19 on distance learning from a very current perspective. Although we are not fully prepared, the field that the communication technologies adapt was the fastest one for distance education. Of course, the situation questioned both the adequacy of the existing technologies and the skills of the stakeholders like students and teachers who are using this technology. So starting from this point, we wanted to develop a model based on the transformation of XR, extended reality technologies, into a more effective, strong, and sustainable systems, especially in the field of distance learning. So our model is based on the basics of XR, gamification, and assets. So first, I would like to start by explaining why we are based on these concepts.
We can't see the presentation right now.
Yeah, I just started the sharing right now. Don't worry.
Okay.
It was just a cover. That's why I didn't share it.
Okay.
Okay, now you can see.
Yeah.
Oh.
I'm really a very huge screen, and there are some presentations, other presentations quite it. That's why
You can turn it into presentation mode.
Can you see my presentation right now? This way?
Yeah, like a PowerPoint screen. Not.
Yeah,
not
unfortunately,
like
I have some more notes. That's why I cannot do it this way.
Okay. Okay.
Yeah, maybe keep this way. Okay. So you will see on the screen, but I will talk about them. You will not. I will not just make you read all of these things. Okay. So first of all, of course, we start with the game, as this event is about gaming and how we can adapt game concepts to the education and learning. So the rules, the values, the competition, commitment, actions, entertainment, and interaction, which are the building blocks of gaming, and also our model. So of course the game is of course not alone itself to explain a system, but because we do a design and educational game model, therefore we search for the answer to how we can use the concept of game in the learning. So here are some quotes that we reference for our game concepts, and here they are. Jasper Joule calls the game a rule-based formal system with a variable and quantifiable outcome, where different outcomes are assigned different values. The player exerts effort in order to influence the outcome. Player feels attached to the outcome, and the consequences of the activity are optional and negotiable. Also, Sid Meier says that he calls the games as a series of meaningful choices. Adams and Rawlings says that the games are one or more occasionally linked series of challenges in a simulated environment. And that's why we choose starting with the game. But of course, game is not enough to tell about our concept, so we have to turn it into gamification for learning. And since our model aims to integrate the game concept and aesthetics within the distance learning, we proceeded through gamification. And the previous presentation was about gamification, so I don't want to go into too much details. But as you see, gamification is all about turning the game concepts, game dynamics into learning systems. And first of all, playing games is an orientation in learning. And Huiza says that games present a natural form of teaching. And with the visuals, audio feedback, user interfaces, and controls generally follow certain kinds of parameters which are included in our system. And also, we already talk about the the problems around the learning systems right now as we are making the distance learning systems. But the major problems around the student motivation and engagement are still available for our model. And sorry for that. And according to CAP, the gamification is using game-based mechanics, aesthetics, and game thinking to engage people, motivate action, promote learning, and solve problems. And also we can say that gamification is the use of game thinking, approaches, and elements in a context different from the game. So gamification is different than game, and it is much more applicable to the learning. And so we have some concepts in gamification for educations, which are the users. We can call about both teachers and the students, the challenges that the user perform and progress toward defined objectives, which is learning and teaching. The points are that are accumulated with the result of executing tasks that we can understand as giving the grades. The levels are which user pass depending on the points. So the levels can be topics. The badges are which serve as a reward for completing actions that can be, again, the badges and the points rewarded. And ranking of the users, it's as we are talking about the classroom experience, then we can get a list of their achievements and such kind of this. So of course, the connections between games and learning cannot be considered as one-dimensional and channeled. So in other words, the gamification of education requires addressing and associating many different disciplines in depth, which can be constructivism, experiential learning, social learning, scaffolding, mastery learning, surface and deep learning, GIS learning principles. These are all the concepts that we were making research about them before designing our models. And of course, when we are talking about education systems, as you know, Bloom's cognitive and the Bloom's taxonomy of education is very generally accepted. So we started with Bloom's taxonomy, investing in it. And as you know, the Bloom's cognitive domain handles the learning process in 6 stages from knowledge to evaluation. And the taxonomy of affective domain is also about acquiring, responding, and receiving, evaluating, and organizing and conceptualizing information, and finally characterizing it. But this taxonomy was like very 54-year-old, and so there was a revision made by 2 guys, Anderson and Krautwohl, and they take the Bloom's taxonomy into another step from remembering to creating, which is we think very important. The steps are remembering, understanding, applying, analyzing, evaluating, and the most important part, creating the things from that you learned. So I would like to give some quotations more where we used as references for XR and how we can apply extended reality to learning, maybe as an immersive approach. The physical world is blending with the virtual content, and people are living in an extended space enhanced through digital technology. With the growing impact of digital content, the experience of learning and teaching in higher education is being changed significantly by Wang, Newton, and Lowe. Emerging VR and AR for the first time offers an authentic hyper-immersive learning experience in a technically feasible format for large cohort teaching with a decent price. And the last one is the blurring of boundaries between the learning space and context challenge many established theories of learning. The most significant impact of VR on learning may not be about the technology itself at all, but rather the radically different potential configurations of learning space and context that VR tends to promote. Here are the starters of our model ideas. And before doing that, we just look for the previous models that can be applied to distance learning, not necessarily for XR, but some models are also used for XR. We started with the Kolb's experiential learning model. This is one of the oldest model which can be applied to distance learning and also maybe XR. According to Kolb, learning is made through the process of experiencing in a cyclical and continuous manner. Learning is the process whereby knowledge is created through the transformation of experience. Knowledge results from the combination of grasping and transforming experience. So the first model the experiential learning methods that came to mind which is based on the learning cycle of Kolb, is a study in which the same content can be approached from different angles and is described with different stages of learning by experiment. And once you can understand from this simple model, ELM is defined as a 4-stage cycle consisting of 4 modes: concrete experience, reflective observation, abstract conceptualization, and active experimentation. Here I want to explain a couple in a words. So concrete experience is doing or having a new experience or situation which is encountered, or a reinterpretation of an existing experience. Reflective observation of the new experience is stepping back from the task and reviewing what has been done and experienced. Abstract conceptualization is the process of making sense of what has happened and involves interpreting the events and understanding the relationship between them. This gives rise to a new idea or a modification of an existing abstract concept. And the last one is an active experimentation, is using theories to solve the problems, making decisions. And here the learner applies their ideas to the world around them to see what happens or maybe create something. The second model was the APT model, Assessment, Pedagogy, and Technology model. And this model is mostly built on the pedagogical aspects of learning, while it is supported by technology and assessments. In the pedagogical aspect, the model analyzes the students' teaching goals, design of teaching contents, and the design of teaching activity. And while you can see these have some common roots and places, in the assessment aspect, the model emphasizes both formative and summative assessments, where the system offers feedback and helps the students to achieve the task. Formative assessment refers to the ongoing process of students and teachers engaging when they focus on learning goals and understand where current work is in relation to the goal, so that they can take the action to move closer to the goal. Summative assessment is evaluating the student learning and at the end of the instructional unit by comparing it against some standard or benchmark. Finally, the model has a technology aspect which covers the equipment and instructions, including the usability of the tools as functional design elements. Interface design elements such as learning cards, real-time feedback, and navigation are crucial elements of successful learning experience. The model also emphasizes on the art and entertainment to get the maximum efficiency of learning process. When we look at the model, it is seen that there are connections between each basic concept. The individualization is standing between the pedagogy and technology, where the students are in engagement with the applications as an individual approach. The third model is the ergonomy learning hedonic quality model. This multidimensional model proposed by Prebini, Balog, and Aordash is depending on the technology acceptance model, just we call TAME, which is developed by Davis in 1989, who explains user acceptance in terms of perceived ease of use and the perceived usefulness of any technology for learning. The conceptual model has 3 dimensions: perceived ergonomic quality, perceived learning quality, and perceived hedonic quality. And also in return, each dimension has 2 sub-dimensions. The first concept of the model is perceived ergonomic quality, and it has 2 facets such as ease of learning, how to use it, its learnability, and ease of use, where learnability refers to the ease of understanding, learning, and remembering how to use an application for learning. Perceived learning quality has also 2 facets as perceived efficiency, which is a distinct construct pointing to a better and faster understanding, and perceived usefulness as improvement of knowledge, usefulness for testing of knowledge, and support of learning. The third and the last concept of the model is perceived hedonic quality, which also has 2 facets, such as cognitive absorption, which is the state of total engagement when the attention is focused on the interaction with the application, and perceived enjoyment refers to the enjoyable experience within the application. The third model and the last model is that we have made a research about it, were the interactive persuasive learning model. So there has been a vast interest in discovering how computer and information technology influences, motivates, and persuades people to change their behaviors and attitudes. According to Fogg, as a tool, a computer is designed to influence people in changing their behaviors and attitudes by increasing people's abilities or by making a task easier. As presented by Zulkifli in 1916, IPL model is based on 3 broad categories: interactive media features, layout and consistency, simulation, navigation, and minimal input device, and interactive persuasive elements as motivation, experience, cognitive and emotional appeal, and learning outcomes, performance, and satisfaction. In this model, the four interactive media features are the interface as layout and consistency, the simulation, which can be simple 2D or complex virtual 3D, the navigation, and minimum input devices as usability factors. The effects of interactive media features are categorized as motivation, experience, cognitive, and emotional appeal for learning activities. Motivation leads to positive performance outcomes. Cognitive is understanding the learner's thought processes. Emotional appeal is the aesthetic approach to the design with human emotions, effects, feelings, and moods. And finally, the final experience is all about learning processes. As learning outcomes, Zulkifli puts performance and satisfaction as the end of learning process. It is about recognizing the changes in his knowledge and the feelings after learning with the interactive media, which may have an impact on persuasion. And so before coming to explain our own model, let's go back to Kolb's learning cycles, which is included in our model too. So after examining the different training models applied in the previous section, we searched for a more efficient model for the XR. The main reason for this was that the existing models did not bring enough extended reality opportunities and advantages to the fore. However, it was really important criterion to include innovations offered by developing technologies within the model. So the four cycles of the learning for Kolb is accommodative learning, divergent learning, assimilative learning, and convergent learning. I will just briefly explain what are those. Accommodative learning style is a doing and feeling approach. People use other people's analysis and prefer to take a practical and experiential approach. The divergent learning style is an observatory approach by feeling and watching. People are able to look at the things from different perspectives and prefer to watch rather than doing. People perform better at idea generation and critical thinking. Assimilative learning style is a logical approach where ideas and concepts are more important than people. The focus is much more in abstract concepts and ideas and more appropriate for technical and analytic models. And the last one, the convergent learning style or the way is a problem-solving approach. People prefer technical tasks and find solutions by decision-making. A convergent learning style enables specialists and technology abilities. And let's move on to our model, what we have proposed. It's the, as we call, it's an agile mode, which is immersion, gamification, and assets. So you can see that we already included the learning styles from Kolb, and you can see the titles and where these are close at is much more related to their own topics. So addressing the Kolb's learning styles on three pillars, the agile model has been developed to create an efficient and balanced structure, especially in extended reality applications for distance learning purposes. The model, which is built under the main headings of assets, gamification, and immersion, also includes technology, content, and experience subtitles in the learning cycle. So I will just briefly describe what are those. The immersion is defined.
You please just compile what you're going to say.
Okay, because
sorry about that. Sorry, interrupting.
No problem. It was really a very long speech, I know. I will just briefly describe what are they and let I talk about it, the results. Okay. So immersion is defined as a degree of involvement with something. Gamification, as we talk about, is about making the game dynamics work in the learning model. The assets are the resources that are used to deliver information for the purpose of training and development. So we do have this content as themes, task, flexibility, and easy to learn. The contents specify the subject content and approaches covered by XR training. The themes are the topics we are included in the education. The tasks are the experience-based trainings. The flexibility is the road student takes, whatever their capabilities and abilities are. And easy to learn is about the application should be really easy to learn. And also the technology expect is including soft skills, practice, having fun, and easy to use. Soft skills is the topics that are out of the learning structures, such as sharing, such as leadership, or these kind of skills, which are also included in the education. Practice is making like an experimental learning, doing things with by hands and minds. The enjoyment is having fun while you are doing and completing your tasks. And easy to use is about the applications that should be really easy to use with user experience. And the last section as an experience is about three titles like attention, outcomes, and real life. The attention is just not a stimuli, but also including a number of processes, including filtering the problems, perceptions, and balancing these. The outcomes are learning outcomes, which might be summarized as what you learn from what you get. And real life use is very important step. You have to use what you learn in your real life. Otherwise, it will be just a logical, just a theoretical subject, which is not included in our model. So here I want to speak to Kutay to tell about how we analyze all of these models, the four models and our model, and we consider our model. So Kutay, can you hear me? Yes. Can you see my presentation?
All this, let's say, theoretical, research, we had to do something quantitative as well, because we knew that our model had to be justified somehow. So we decided to use analytic hierarchy process to compare our model with the other existing models. And of course, we will have a short example. I will give a short example as well, what our model really does when we, teach a class. But still, analytic hierarchy process is a process where you have to know the criteria and you have a goal. So you are trying to find which alternative suits your goal. And our goal is to find the best learning or teaching method, learning model or teaching method. And we had to pick criteria, choose criteria for it. And we did some research. We talked with, in addition to the research, we talked with professors and students and other, attendance of classes and education, educators. And we have come up with 11 different criteria, which were these. Now, these criteria are, I will not read all of them. These 11 criteria are important, are accepted to be important in teaching. And out of these 11 criteria, 4 of them would be found more important than others. All those criteria, all 11 criteria were pairwise compared to each other, which means 55 comparisons. And out of these 55 comparisons, 4 of them having up-to-date and new course materials, keeping student interest, imparting soft skills, which is stuff like leadership and empathy and stuff like that in a class, and having practice opportunities like having labs or studios were deemed to be the most important 4. Closely, let's say, followed by the I criteria, which is implementation of course subject in real life. This is actually something that the students keep asking all the time. What are we going to do with this knowledge in real life? So it wasn't a real surprise that it's got, in front of 6 other criteria. Now, with this criteria, we also had to compare our goals, our alternatives, which were our models, learning models here. And so when we compared our learning models with our criteria, let's say in here, we are talking about all those 11 criteria and how those criteria are weighted in those models. So we have 5 different models. The first one, A1, is our model, the one we are proposing, asset-based extended reality model. And the other 4 models are the extended existing ones. And we have compared each of these criteria, again, together to each other with respect to this, these 5 learning methods, these 5 alternatives. And at this point, their weights have come up. So when we have those weights and those priorities from the criteria, we can just do a simple mathematical sum product, and then get the results for each of the alternatives, which would mean, let's get to the next one, which would mean that we will get our scores for each of the 5 alternatives. And as you can see, alternatives 1, 2, 4, and 5 are close to each other, with 1, the model we are proposing getting the lead, followed closely by the second model, and then the fourth and the fifth, and the third model getting a little bit behind of the other four. Now, although we don't really have any studio or lab equipment available in our proposed model, what's our proposed model? What are we doing in that? What's asset-based, XR learning means? We can get other, criteria in an easy way. We can just get their requirements met easily. Think of something like this. We are in a classroom. We are talking about something, for example, we are in an architecture class. Let's go with that. And we are talking about the Leaning Tower of Pisa. Now, when you talk about it, you may use, videos, you may use pictures on the board and stuff like that, and you can just keep telling the students about it. And then someone can ask something that you haven't thought of putting there, something that needs to be, shown, but you cannot really show it because you don't have the material at the moment. But in an asset-based virtual reality, let's say, simulation in the model, everyone is wearing their headsets. They are distant learning, yes, but they have headsets. They can actually see the class through 3D models, and you have your assets ready. You have already modeled the Leaning Tower of Pisa as a 3D model beforehand, and you have it. So you can just take it from your, list of assets and send it to each student at the same time. So they can just see it in front of their eyes and just play with it, turn it around, check it out, maybe put, pull it apart and put it back later on. They can do stuff like that, which will give them the ability to play with the tower itself and to, experiment with it. You can do stuff like that in, chemistry classes, for example. They can do lab stuff at their home without going to the lab and with no danger of blowing something up. So this actually gives them gives the students the ability to interact with the tools and the class easier. And this also gives the teacher the ability to, prepare better material for their class, because you don't need to be, limited with, let's say, videos and pictures and stuff like that. You can just get the thing 3D modeled and ready for the class beforehand. And that would be, I guess, mind-blowing for the students. I don't know. I would say if I was a student, I would love to see some mathematical functions in, real life, just coded out and shaped and stuff like that, instead of trying to write them in, computers and see them in 2D, monitors. I would love to see them in 3D shapes, for example. So this is what we are actually, suggesting in here. Yeah, that's it.
Yeah.
Okay, thank you. Thank you. This is very interesting, I must say. And we see the multidisciplinarity. I mean, I think one of them are from mathematics department, and two different disciplines work together and did a great job. Thank you so much. Now we exceed the time, unfortunately.
Sorry for that.
Okay, we came to our third presentation, which is going to be presented by Atakan Coşkun. And the three co-authors are from Middle East Technical University. One of them is, Atakan is from Computer Education and Instructional Technology, and the other authors are from Industrial Design. Again, we see different disciplines in the presentation. And the title of the presentation is Exploring Success Criteria of Instructional Video Design in Online Learning Platforms. Okay, Atakan.
Okay, thank you. Can you see my screen?
Yes.
Okay, great.
I see your screen.
My name is Atakan.
Sorry, could you please turn it to presentation view? Or okay, or you can proceed like that. Okay.
Yeah, I want to use like that.
Okay, thank you.
My name is Atakan. I am a PhD student at the Department of Computer Education and Instructional Technology. Today I'm going to present the qualitative study named as Exploring Success Criteria of Instructional Video Design in Online Learning Platforms. I conducted this study together with Elif and Gülşen from Department of Industrial Design. This is a qualitative study, as I said. I will complete my presentation in 4 steps. Firstly, I will give brief information about introduction and background. Then I will be mentioning about methodology of the study. Then I will show you findings of the study. Next, I will close the presentation with discussion and implication part. Let's start with introduction and background section. As you know, online learning platforms has been very popular in the last 2 decades. Millions of people are using these platforms for their formal and informal education. Depending on that, many type of instructional videos are being used in online learning platforms as multimedia learning tools. Also, learners' satisfaction have a positive impact on the success of online learning platforms, which affects learners' satisfaction directly. And also the number of the study related to online learning platforms design and learner satisfaction with them are not enough. Also, researchers cannot understand the reasons why learners stop taking online courses after their initial experience. And also, there is a lack of design guidance related to instructional videos. When you consider these problems, we aim to investigate users' expectations, satisfaction, and also users' definition of success criteria for online learning platforms, and propose some some design guidance about instructional video and online learning platforms. To collect data from the participants, we benefited from 2 instruments. One of them is semi-structured interview. The other one is eye tracking technology. I want to show interview questions briefly. The language of it is Turkish, but I want you to have a little bit information about that. In this part, we got the data about their demographic information. Then we collected the data related to online learning platforms in this part. As you can see, in this part, we also supported our interview questions with UX curve technique. UX curve can be used to understand learners' positive and negative experiences. And also we use it to learn our participants' negative and positive opinions with online learning platforms. Then we acquired opinions of the learners about 3 different types of instructional video they watched. I'm closing and back to a presentation. Also, we used, as I said, eye tracking data to learn visual behaviors of our learners. Our study consists of 2 stages. In the first stage, we focused on online learning platforms. We used semi-structured interview here to learn participant experiences about online learning platforms. As I said, we used UX curve technique to deeply investigate their experiences with online learning platforms. In the second stage, the participants are asked to 3 different types of instructional video. While they are watching video, we measured their eye movements in the study. Then we applied semi-structured interview session again to learn their opinions about 3 different types of instructional video. These are the our videos. Three different type of instructional video includes animation-based video, video with instructor's hands, and video with instructor's face. We selected this video because they are frequently employed in online learning platforms. This is the reason. These are our participants. We collected the data from the 10 participants. All of the participants have an experience with online learning platforms. This is a precondition for being a participant in this study. After collecting data and transcribed them, we analyzed, depending on Delano-McLean information system success model. We used updated version for analysis process. This is the findings of the study. Information quality is mostly mentioned by our participants, which means that video design play an important role on the success of learning platforms. Also, most of the participants mentioned about usability, user-friendly interface and feedback mechanism. This means that usable online learning platforms and feedback mechanism in online learning platforms play a critical role on learners' satisfaction. Also, most of the participants want to see source files, exams, practice problems, case studies. They find these elements of online learning platforms very useful in online learning platforms. As I said, we also collected data from the participants. As you can see in the first video, the participants' visual behaviors are messy. In the second video, they fixated on instructor's hand. And in the third video, most of the participants fixated on learners' eyes. This is a typical gaze behaviors. We are expecting that. However, most of the participants were distracted by the appearance of instructor. We are not expecting that. Most of the participants stated that they are distracted by tattoos of instructors. Also, eye movements show that they have fixated on tattoos of instructor. In this gray area, you can see fixation, total fixation duration on tattoos, and count refers to number of the participants who fixated on tattoo. Which means that the appearance of instructors' instructional video play an important role in a learner's satisfaction, because it can affect their visual attention. Now I will close the presentation with discussion and implication part. Learners want to find what they are searching in online learning platforms quickly. Learning paths can be used in online learning platforms to guide learners. They are finding learning paths very useful because it guides. They can show where they are in online learning platforms. Also, feedback mechanism is important in online learning platforms. They want to monitor their progression. They want to get feedback about their performance. For this, completion percentage or content tree displaying progress can be used in online learning platforms. Also, as I said, instructors' appearance play a crucial role in a learner's satisfaction. Also, eye tracking data showed that learners' gaze behaviors can be affected easily by the appearance of instructors, such as tattoo, T-shirt, or their accessories. Also, there is a significant relationship between video content and video design. Video content, video design, and learner satisfaction. Instructional videos with long duration can be divided into smaller parts, like 5 or 10 minutes parts. Also, speed is a critical point in online learning platforms, especially in animated-based video, because it can directly affect their visual attention. Most of the participants mentioned about that. Instruction designer or multimedia designer are recommended to pay attention to this topic. Also, most of the participants state that they are like seeing simultaneous video. For instance, MIT OpenCourseWare, it results in positive emotions for learners in online learning platforms. Finally, I want to mention about system delivery. In this section, in this part, learners are very happy with seeing source file, case studies, and exams. They are challenging them to learn something. Because of that, instructional designers are recommended to put these instructional techniques into online learning platforms. That's all. Thank you very much for attention. I will be here for your questions. I wish you, all of you, healthy days. Thank you.
Very much. We will receive the questions at the end of the session. So let's go through with the fourth paper. The title of the paper is Challenges in Synchronous E-Learning in Architectural Education. The presentation, the paper will be presented by Meriç Altıntaş Kaptan. She's my PhD student, I must say. And the co-authors are Ece Medes and me, Aslıhan Ünlü. Okay, Meriç, let's hear you.
Okay, thank you. I'm sharing the screen right now. Is it okay? I think it's okay. Okay, thank you. Hello to all. My name is Meriç, and today I will present our study titled Challenges in Synchronous E-Learning in Architectural Education. Before I begin, I would like to note that the data presented here represents the views before the coronavirus pandemic. So, to begin with a brief introduction, distance learning, as the name suggests, implies a form of education in which learners and instructors are not physically present at the same place. Its first historic reference can be traced back to the Boston Gazette, in which weekly mailed lessons were featured in. In time, different forms of communication tools began to appear and change the course of distance learning. First came the printed materials, which revolutionized the exchange of knowledge because the students and the instructors were no longer have to be physically in the same room anymore. And then came electronic communication tools such as TV and radio, and they enabled to reach wider audiences. And then finally came the internet, as we all know today, which introduced the online delivery of information without any time or location-dependent limits. So at this current stage, the crisis of coronavirus has caused a widespread use of e-learning tools and methods. However, adoption of remote teaching methods still preserve their novelty. And in order to support traditional courses with such methods, the current obstacles and assets regarding e-learning methods needs clarification. Besides, the challenges from the learner's perspective based on the professional field need investigation as well. Architectural education is a hands-on training, and it includes numerous applied courses, and that's why it's often assumed to be relatively difficult to accommodate distance education methods. However, with the reuse of modernist buildings project, which was an Erasmus Plus partnership project running between 2016 to 2019, the project aimed to initiate a joint master's program in which both synchronous and asynchronous e-learning methods would be employed. And the synchronous methods would allow for real-time cooperation of other partner universities which were located in other countries. Therefore, the synchronous e-learning efforts covered in this study experiments with the possibilities and limitations of the current conditions. The study aims to investigate the advantages and disadvantages in synchronous e-learning. It aims to disclose the learner's attitudes and to provide an explicit evaluation of the participants' perspective. And by doing so, it aims to contribute to the elimination of any inconveniences on the matter. So the study presented here has three main steps, and the first step of the study is the questionnaire design. The questionnaire had been designed by the RMB ITU team, of course with the contributions of other RMB members, and in total it consisted of 10 questions. The questions can be grouped under three main categories as shown here. The first group includes 6 questions. The first two identifying the characteristics and settings of the distant lecture attended. And the third question is about demographic information, asking for age and gender data. The remaining 3 questions were about students' previous experiences on distant lecture. The second group here is Likert scale questions, which explore the comparative personal assessments of the respondents. And the final group, which is a standalone question on its own actually, is an open-ended question where respondents are asked to provide any further assessment or recommendation. The second step of the study is the execution of distant lectures and data collection. The distant lectures were done starting from 2017-18 spring semester until the end of 2019-20 fall semester. In total, 7 different distant lectures were executed using Adobe Connect program. And after each session, a survey was distributed to the participants, and in total, 122 responses were collected with the survey. Here we see a brief description of distant lecture characteristics. We can see that the majority of the distant lectures executed were of undergraduate or master's degree level. And technology was the main subject covered in this distant lectures. Again, the majority of the lectures were using theoretical method. There was only one lecture which employed the method of Design Studio, and most of the distant lectures employed either the setting of S1 or S3. S1 is being a classroom lecture given by a distant lecturer using classrooms like data show or projector screen. S3, on the other hand, is distant connection to an online theoretical web lecture. And again, there was only one lecture using S5 setting, and it is a design review using a web-based platform with screen sharing option. In general, 4 of the distant lectures were run in Turkish, and the remaining 3 were in English, which was a second language to all of the participants. After the collection of data, the third step was the assessment of data through thematic analysis. In total, 33 responses have been collected for the open-ended question, and the data was analyzed in detail using the thematic coding process. The process actually includes the identification, organization, and systematization of the raw data, which is the respondents' opinions in a text form. And it is examined in detail to generate key ideas, concepts, and categories. And primarily, the data has been read, reread, and categorized in order to identify some patterns or a shared vision among the respondents. And the repeating ideas and notions which were identified were used in order to construct the themes. Statements which express the same idea were grouped together and then further organized under the themes. So here we see the characteristics of the open-ended responses. We can see that only two participants stated that they had a past experience regarding online lectures, and the remaining 31 respondents identified themselves as the first-time participants in any online lecture. And the age and gender distribution of the respondents are provided here. We can see that the age range is between 19 to 37, and the mean is 23.5. And the ratio of female respondents was more than that of male respondents, but not with such a big gap. And in general, only 30% of the participants attended a distant lecture of their native tongue. Eventually, with the thematic coding, the responses have been worked on several times, and in total, 33 responses have been collected. However, 62 statements were generated from these responses, and these statements were categorized under the 4 main themes generated by the researchers. And here we see the first grouping, main category, which is the general comments. General comments are statements that reflect personal views or tendencies in general terms, but they do not provide any evidence, or they do not establish any cause and effect relationship. Being positive or negative, they can be grouped under positive remarks or negative remarks, and there were some answers which were grouped under neutral comparative judgment. The second and third groupings are assets and drawbacks. Assets and drawbacks are subjective evaluations, and they are often supported by cause and effect relationship. And again, based on their being positive or negative, they're grouped under assets or drawbacks. And the final fourth grouping is the suggestions, where any proposal or advices provided on how to correct the problems are grouped here. The results presented here is based on these 62 statements. And here we see that the responses and statements were mostly concentrating on drawbacks and comments, which were equal in ratio 34. And it was followed by assets with 24% commentary ratio, and subsequently suggestions with an 8% ratio. And if we examine the results in detail, we see that the positive remark is the prominent subcategory with a commentary ratio of 16%, and it's followed by greater productivity in assets and technical problems and drawbacks. And after that, we see that negative remark is following that with an 11% of commentary ratio. The second assessment, this comparative assessment, on the other hand, was based on the total number of respondents, not number of statements. The responses to the open-ended question were examined in relation to certain questions of the survey, and these questions are Q7A, Q9A, and Q9B, which were Likert scale questions. And Q7A asks the respondents whether the distant lecture attended is any different from other traditional courses in general. And Q9A asks whether the respondent is willing to attend any other future distant lecture. And Q9B identifies the respondent's preference in attending the same distant lecture if the option was provided for both settings, for both e-learning setting and for both traditional setting. So the number of respondents who had either commented strongly disagree or disagree reply to these questions were analyzed together with the open-ended question. And we basically looked if there are any conflicts, actually. And the outcomes of the analysis revealed that Q9A has revealed no contradiction with the open-ended questions, However, Q7A and Q9B, in these answers, there were some slightly contradictory answers. So accordingly, this finding might indicate that regardless of the positive statements and advantages addressed by the respondents, students or the participants might still show a preference towards the face-to-face lecture instead of a distant one. In overall conclusion, we can say that the open-ended question of the survey had a response rate of 27%, which might be due to several reasons, such as the broadness of the subject being investigated, or the relatively limited experience the participants or the students have had in order to elaborate the issue. And also the question itself might be the reason, because open-ended questions are known to time and effort requiring questions. And the study also revealed that the mostly referred challenges in distance education was technical problems with 12% ratio, 13% ratio. And it was followed by lack of efficient communication and interaction, and followed by personal distractions, which are either caused by ambient conditions or the lecturing methods themselves. And the least referred challenge was time inefficiency. In general, we can conclude that the students were showing a hesitant attitude towards distance education. Even the participants who were pleased by the positive aspects of remote teaching were still in favor of attending face-to-face lectures when compared. And as for further studies, the personal assessments of the participants need to be investigated in relation to gender and age data as well. And of course, the impact of lecture language was not covered in the study. However, it also needs to be further examined. Thank you for listening.
Okay, thank you, Meriç, just on time. Okay, now we came to the final presentation of the session and final presentation of the conference. And the title of the presentation is Inclusive E-Learning Platform, Adaptive Design for Students with Learning Disabilities. And it's going to be presented by Alessia Brichetto from University of Florence. Okay, hello, Alessia.
Alessia won't be here today, so she sent a video, so I'm sharing it right now.
Okay, thank you.
Hi to everyone, I am Alessia Brichetto from the Department of Architecture in Florence. Today I show you the work titled Inclusive E-Learning Platform, Adaptive Design for the Student with Learning Disabilities. In particular, I will present you the result of an experiment carried out in 2019 to identify the design requirements necessary for development of the PUDCAD e-learning platform. The objective of this work is the presentation of a design tool useful for development of an e-learning platform, for example, virtual learning system, for university educational sector. The research is unsettling about the possible evolution of virtual learning system, and in particular the Moodle platform used in universities. The methodologies was being applied in a transversal way and was being characterized by the application of methods based on user involvement, respect of the human-centered design process and approach. The result of the experimentation were useful for the definition of the design requirements of the e-learning platform of the PUDCAD project. In detail, the work was organized by following the research steps were illustrated: analysis of literature background, user needs analysis, estimating user exclusion, creating of an exclusion evaluation tool, and design phase. The work is therefore finalized to outline practical solutions and strategies. Whose objectives are: evaluate the actual inclusive potential of the technologies, designed to include people with specific learning disability and visual and auditory impairments, technical aspect, accessibility and use of content, interaction style, validate theoretical models and on collaborative learning, didactic and pedagogical aspect, teacher's side, for example, organization, creation and sharing of didactic materials, didactic and pedagogical aspect, teacher and descendants element, for example, universal access to information, organization of the study, teaching, strategies and motivation, user experience, how to motivate and foster socialization, and possible project scenarios. And workflow was focused on the human-centered perspective according to ISO 9241-210. The methods applied were used observation and exploratory questionnaire, interviews and focus groups. Simulation tools such as the Empowered Simulator developed by the Inclusive Design Center of Cambridge were also used in the evaluation phase. The evaluation phase was characterized by two phases. Step 1 is preliminary accessibility review, and step 2, user-based evaluation, in particular questionnaire, observation and thinking aloud, and focus group. The evaluation session involved 120 students, including 8 students with a specific learning disorder, and 1 student visually impaired, and 1 deaf student. In addition, 23 European and extra-European students were involved. The learning system analyzed was the platform of the University of Florence that uses Moodle. To carry out the task session, the activities and functionalities present with the Moodle platform were analyzed. Through the task analysis, in this phase, it was possible to identify its quality and compatibility within the main technical standard. The evaluation phase included the dissemination of a preliminary questionnaire and then a direct observation phase. The questionnaire was disseminated through the Google Modules application and was aimed at recording the following aspects: frequency of use, multimedia learning support tools, possible problem and critical aspects such as collaboration and knowledge sharing, finally, external tools and platform used for study. After the questionnaire, students were asked to perform tasks identified in the task analysis. The activities observed were different. Some concerned the technical regulatory aspect of accessibility. Others concerned the learning dimension of the student. In particular, access to information to study, understanding of teaching material, for example, reading, writing, self-organization, re-elaboration of information, and finally sharing knowledge among colleagues in the course. The end of the trial session, focus groups were conducted with user and individual comparison session among students. The individual session served to define their needs. Within the focus group, thematic discussions were held on aspects related to accessibility, use of content, and possible project implementation of the evaluation system. The focus groups lasted 4 hours and was structured in the following operational phase. The phase 1 presentation of the summary of the test result, direct observation and objectives of the focus group. The phase 2 thematic discussion of the user observation result. And finally, phase 3 empathy trial use the in-period simulator of the Cambridge University. The results are many. Now you will see some of them in detail. With regard to access and understanding of the information to be studied, 30% of the observed users highlighted a difficulty in understanding the course structure, training objectives, and verification methods. Only 20% of users use the mobile application, as it does not have all the features of the mother platform. 17% of the students said that there is a lack of tools to customize the platform, for example, text size, layout, and distribution. And specific learning disorder subjects, and in particular for games, found the lack of effective communication tools for understanding the training activity, timing, objectives, and etc. in relation to the actual path, for example, evaluation, exercise, and etc. The visually impaired student expressed difficulties in reading the laterally positioned text fields, menu column, news, and in absence of tools such as text enlager and voice synthesis. This is an external tool, not internal to the platform. The deaf student expressed the lack of the senior languages dictionary and traditional dictionary and translator. With regard the understanding of teaching materials, reading, writing, self-organization, approximately 85% of users highlighted the lack of multimedia materials. The lessons are structured by the teacher, and not everyone takes care of this aspect. 30% of SLD subjects found the lack of tools for the selection and highlighting of the text. They also declared that in 2 years of course, no teacher explained the glossary function. The hearing impaired student expressed the lack of seeing language dictionary and traditional dictionary and translator. These tools are on the hand useful to deepen the learning process and to provide elements for understanding the theoretical terms of words that are not now both in Italian and other languages. Respect information processing and sharing knowledge among colleagues in the course. The 95% of users highlighted the lack of multimedia agents or information processing tools, video interactive quizzes. In particular, the absence of area dedicated to the notes or notice identification of the text and its exporting to external files for their subsequent processing. Respect the sharing knowledge among colleagues in the course. 40% of the users observed at elderly used the workshop activity, and only 15% of the forum. Chat is used by almost all students in a fairly activity way. As far as the wiki feature is concerned, no student was familiar with it. The user observation and focus groups allowed to define design scenarios that mainly concerned the following aspects: customization and user learning system adaptability, strengths and tools related to multimedia, hypertext dimension, podcasting and streaming when then possible, enhance student side functionalities for knowledge acquisition, creation, and sharing, introduce codes that support gamification, motivation, generate a positive learning experience, monitoring and support of individual and group study, transversally of learning from digital to tangible, increasing the diffusion of the digital text box and their compatibility with a learning system, strengthen the collaborative section so that it can guarantee the exchange and the collection of processed materials rather than dialogue through the chat, interconnectivity between digital and physical environment, interactive whiteboards, increased dissemination of assistive technology. Finally, assistive technology as in universal design for learning, for example, should not be demonized, but integrated with respect to the objectives and the needs of the user. On the basis of the results achieved during the user observation phase and focus group, the design requirements for the current Moodle platform were identified, as well as defined the new design concept. The first consideration concerned the functionality of Moodle. For example, this type of learning environment brings a series of advantages ranging from its worldwide diffusion with the university. Internationally, the Moodle user community is the largest. Now, its compliance with technical regulation and the possibility for organization to customize the learning environment at very low cost. In general, these are the many advantages of Moodle. The final result of the work is to illustrate an operational evaluation design strategies and experimental platform for inclusive learning. The research highlighted the need to strengthen education tools in terms of accessibility and usability, and in particular collaborative learning. In addition, the research highlighted the need for the social network-based system that supports not only accessibility, but also autonomy, socialization, and the ability to collectively build new meanings. The results have been further tested within the PUDCAD project, and the University of Florence team is currently working on the platform. Now I will present you the progress of the PUDCAD platform, and in particular the future of the e-learning section developed by LED team at University of Florence. The PUDCAD game platform is characterized by 3 sections: a game download section, a tutorial section, and learning section. In addition, features such as support and community creation have been included. Let's see in detail the e-learning section. This is the architecture. We are currently in the full programming and scripting phase of the website, in general of the web platform. The website is already online, but August we will publish the final version. The e-learning section features a cascading path that allows students to learn the basics of the universal design principles. Each lesson will contain theoretical and applicative content related to the gaming experience. Through the e-learning path, students can deepen their knowledge of universal design issues and deal with a collection of design case studies that will allow them to enhance the learning experience. Each lesson can be commented by the community. User can leave a comment or ask questions. This will allow us to have feedback on the effectiveness of the lesson. Now, this is the preview of the graphics that the lesson will have. The theoretical framework will be connected to related scenarios, realized through environment graphics and contextualized within the real space. And another interesting function is scenarios and quizzes. Scenarios and quizzes will allow to strengthen the learning process and to confront the project dimension in a concrete and dynamic way. At the end of the course, students will receive a certificate of participation and will be invited to share their project experience with the community. Finally, we are testing assistive technologies, tools, and plugins to be integrated into the PUDCAD game platform to increase the level of accessibility to web content. Thanks for your attention. Goodbye.
Okay, now I think we experienced a synchronous e-learning example with this presentation. Therefore, it's a nice final, I must say. I wonder if there are any questions. I have just got one from the chat window. If all the audiences may ask their questions through chat window or directly on the screen. Let's start with Çetin Tüker's question. He said that he doesn't have a microphone at the moment. So his question is to Barış Hoca.
Yes.
The question is, you talked about learning styles in your presentation. There is evidence that learning styles are a myth. And learning is related with the instructional method and what to teach instead of people's learning style. What do you think about this?
First of all, I would like to thank Çetin Hoca for asking this question. I believe in that learning styles might be not classified in personal approach. What I mean, you cannot put a person in one category only. So we have to think with dualities and also with diversity for both the student and the content. We reference Code's learning styles to show that the cycle in our own model addresses all types of student skills and abilities. As you say in your question, we are trying to find out the best instructional method, not based on a single model or a theory, but with augmented abilities and sustainable assets by the help of new technologies and challenges. That's my answer.
Okay, thank you. Now, Çetin Tüker said to everyone, belief is not science.
Yeah, it's commented.
Okay, any other question? Actually, for presentation, we cannot ask, I think, for the last presentation. Okay, if there isn't any question, then I will close the session. I think no questions. Okay, thank you to all contributors and to presenters. Thank you. And yes, thanks a lot. I give my word to the organization.
Thank you, Professor. We are closing our conference right now, so I'm calling our co-coordinators and co-organizers of the project and the conference to make their last speech. First, I want to introduce you Associate Doctor, Professor Dr. Özge Jordan, and she will make a speech right now.
From next chair to another one, I moved. Hello from Taşkışla again. As we said, we would like to host you here, but maybe next time. Now we did our conference very successful, I guess. And I would like to thank to our PUDCAD project partners, all professors, participants, distinguished guests, dear young candidates of PhD and master degree students, our chairs. I also would like to start my last words by offering my sincere thanks to you for being here, participating, contributing to the valuable discussions and sharing your valuable ideas with us. We would like to thank to all presenters and authors of 33 studies, which was presented here in these 3 days, and participating, contributing to the valuable discussions again. We would like to thank to all chairs who are Hülya Kayıhan, Gonca Bumin, Güven Çatak, Birgül Çolakoğlu, Çetin Tüker, Barbaros Bostan, Çakır Aker, Veli Pekka Roti, I guess, and Aslan Ünlütavil for chairing these 9 sessions. If we remember those sessions, the first one was about universal design and education, and it was there were 4 papers presented in that session, and it was moderated by Hülya Kayıhan. And in the second session, it was about universal design and user experiences, and again there were 4 papers, and it was moderated by Gonca Bumin. In the session 3, we had 3 papers. It was about games for change, and it was moderated by Güven Çatak. In the session 4, it was about game design experiment, and it was presented 3 papers in that session, and it was moderated by Birgül Çolakoğlu. In the 5th session, again, there were 4 papers, and the name of actually this, or the theme of this session was about virtual reality experiment 1, and the chair was Çetin Tüker. In the 6th session, it was presented 4 papers, a virtual reality experiment 2, and it was moderated by Barbaros Bostan. In the 7th session, it was about playful experience design. Again, 4 papers were presented, and the moderator was Çakır Aker. In the 8th session, it was about playful spaces and interfaces. Unfortunately, 2 papers presented. We expected 3. And Veli Pekka Roti was the chair. And the last session, you all are here, thanks to Aslan Hoca again for moderating this session. As we all very freshly know that it was about gamification and e-learning in design, and it was presented 5 papers. The score is yours in this session, actually. So we also extend our thanks to keynote speakers from different disciplines and from different expertise in these 3 days. The first one was actually from our PUDCAD partner, Fiametta da Costa. Professor Fiametta da Costa gave a speech about the principles of universal design in PUDCAD project development. And the first day afternoon, Güven Çatak and Çetin Tüker from PUDCAD Partner University Bağı gave a speech about developing a CATE and rich empathy experience for universal design principles, journey of the PUDCAD game. In the second day, we had 2 keynotes as well. Christopher Holmgard, who gave the speech about AI personas for designing, testing, and optimizing games. And Dylan Yamada Rice, she gave a speech about children and VR. And today, we had a speech from Francesca Tossi, again from the PUDCAD Partner University. Her topic was about asking users questionnaires and interviews as indirect observation tools in human-centered design approach. I think that this study is presented and discussed here during these 3 days made a significant contribution to the conference themes as universal design, e-learning in design studies and game and design studies, as well as the PUDCAD project, both academically and in terms of knowledge sharing. As you know, we had this conference online due to pandemic of COVID-19. And after this conference, we hope to see you face to face next time in normal days, not in the new normal days. I would like to say, stay healthy and to greet you all respectfully. Thank you very much.
I will now present you Dr. Demet Dinçay, our co-coordinator and co-organizer. So I'm just gonna shut mine off.
Microphone.
I'm ready. Now we are at the end of the conference, and we especially thank our keynote speakers, chairs, and speakers for their valuable contributions. These 3 days have been very productive for us, and we hope it's same for you. We were happy to be together with our project partners after a long time. Our main project outputs, PUDCAD game and e-learning module of the game, were promoted to all the audience. We met many design people. We had chances to inform about many researchers about universal design and game design in the conference. And we thought that our project, PUDCAD project, was a good example for working together with different design disciplines. We hope our cooperations would be continue. For a last word, PUDCAD project and its outputs will continue to be developed until the end of August. And please continue to follow us via web page and social media accounts. While we close the PUDCAD online conference, wish all the audience healthy days. And as a PUDCAD team, we wish all of you a good day. Thank you very much.
Thank you.
Thank you. Thank you, Elif, and thank you, Chul. Away from us, but she's always here. Thank you. Thank you. Thank you.
And also thank you, Sena.
Sena, yes, special thanks to her. Thanks to Sena for our speaker.
Thank you. So now,
Okay, we don't hear you.
Okay, there was a problem with the voice. So I'm gonna do it like this.
sorry, we would like to give the words to you, our partners. We will be so happy if you share your thoughts about the conference, about the PUDCAD project, and also the other guests, our professors. We would like to hear your voice as well.
Hear you.
Yeah.
Any comment?
Any comments?
No, we didn't hear you.
Oh, maybe you can come here and there was a problem with the voice, I guess.
Okay, as I stayed on my own, I guess, I would like to give the words to our project partners and all the audience. We will be so happy if you also share with us your thoughts about the conference, about the project. Please, the stage is yours. Please, share your thoughts, share your ideas with us.
So I wish also to thank everyone, and it was since now, but it's not finished, a very interesting work altogether, and I appreciated, for example, very much the growth throughout the workshops. So we began with more traditional approach to universal design, checklist, and so on in Milan. And then through all the workshops, I think we arrived to a very more innovative approach, which is the result of the game. So thank you to everyone.
Thank you.
Also,
Okay.
I would like to thank you for all PUDCAD team and all partners. It was a very good project for us. I really enjoyed working on this project with you as a partner. Thank you for all.
Thank you. Güven Hocam?
Well, first I'd like to give the words to our guests. Actually, Christina, would you like to say something?
Yep.
Hello, everybody. Yes, I think it was a very, very great conference, and I think there was such a lot of input for us to work forward in our project. And I should give you so many greetings from Ulrich. He can't be here. He's in many lectures at the moment. But I think it was a great project, and yeah, I think the results are more than I and many thanks to you, yeah, produce the game and so on, and also to Antonella for the e-learning platform. And yes, I'm very happy to be part of this project. And thank you to all the speakers. There's so good things there, and yes, thank you for everything.
Thank you. And Antonella, would you like to say something?
Yes. Thank you for our coordinator, for organization the conference, and all partner and all participant for change ideas, concept and project. Thank you.
Thank you. And now, Güven Hoca.
Okay. Well, yeah. First of all, I want to say that like we made it. So yeah, so it was a very long journey, full of different obstacles. It was kind of like a game actually. So we have completed many levels. We have conquered many different castles in different countries, different cities, and yes, it's been a great journey. And the topic is very exciting, and I think. And it was also a very interesting project in terms of joining different disciplines, actually, but not saying, but actually by doing it. So I think in that sense, it's also I think important milestone for every partner, and for the contributors, for the people who contributed to the conference with their papers. It was also a very, I think, a great diversity in terms of papers, which is very good. So I think they're on the right track. So please follow the project so that we can share the outcomes with you all in future, and hope to work again in new projects. Yeah, thanks.
Yes, Güven Hocam, we can
Thank
go
you.
for PUDCAD too.
The sequel.
Yeah.
PUDCAD 2, the sequel.
PUDCAD too, yeah.
Yeah, but as you know that the sequels really don't work that well.
That's good. Okay, we can change the subject.
But maybe we can start to work on a new subject. So anyway, thank you all.
I have a special thanks to Aslan Hoca. And she supported us at the beginning of the project. We gained lots of experience from her, and thank you so much, Hoca.
Thank you. You did a great job. I mean, we started at the first time with Erasmus Plus project at ITU, and we didn't know what we're gonna do. And I'm glad that I had the chance of sharing my experiences with Demet. And they really did a great job, and congratulations to you all.
Thank you. Yes, it was a great support and sharing of experience is very important. Joel, would you like to say something?
Oh, okay. I wasn't expecting that. Okay. Yeah, for me, it has been really a strange process, to be honest, because I started this project when I was back working at Istanbul Technical University. Then I moved and changed actually 3 countries in 3 years, and now we are in the end, and I am a little bit, sad about it, but also.
Okay. She was frozen.
Some is that we were really struggling with I don't know, budgets and the project outcomes and so many things, and also Antonella knows that, like, there was this also language barrier sometimes, that we had to speak Italian, we had to speak English, we had to speak Turkish, so 3 languages in the same time, but we did it. We
but
did a good job.
That's the fun part, actually, right?
Yeah.
That's the fun part, actually.
Exactly. We learned a lot through
definitely.
through this project. Yes.
And Sena would like to say something.
Okay. Because there is no voice order. So I begin this project. I think I joined this project last year. So it was my first project. So I learned a lot, and it was a really nice time to be in this group, in this between these partners. And thank you all. That's all I will say. Thank you all for your contributions. It was a great pleasure.
Thank you. And Elif, please.
Okay. I don't like talking with a mask, but it was a great experience. It was good knowing you all, and actually they have said very nice things, so I don't have much to say, but it was an experience maybe for a once in a lifetime you have.
And we will solve the budget problem.
Yeah.
As soon as possible.
we become expert about the budget problems.
Elif, don't make us cry.
Yeah, those are painful years, right? Okay.
Okay. Then.
Yeah, that's it. Thank you. Thank you.
Thank you.
Thank you very much.
Yes, thank you.
I hope to see you.
Yeah, actually, the Korean one.
Yep. Take care and stay safe.
Yeah, you too. Yes.
Thank you very much.
Bye-bye.
Thank you. Bye-bye.
For everyone.
Yeah, thank you for participation.
Bye-bye.
Bye-bye.
Hopefully we see us in the
Yeah,
future.
Christina, say hello to Uli. Okay.
Yes, I will say, yeah,
Yeah.
of course.
And
Bye.
say hi to Giorgio.
Yes, sure.
Yeah, also,
Okay.
yes. We
Yeah,
missed
please.
him here. We missed him
Okay.
here. Also, Michaela.
Yes.
Yes, yeah, for everyone I forget.
Okay.
Okay, guys,
Bye.
girls, bye-bye.
Yeah. Great job.
Bye.